Hello class, today we're going to be looking at 6.7, finding equations and graphing lines. So first thing we're going to look at is some definitions, and these are very important definitions, so please make sure that you take note of these. Please make sure that you remember these ones, especially for the test. So when we find the rate of change, which is something that we've done earlier in the unit, we are finding the steepness of the graph, and the common name for this in math the steepness or rate of change is the slope of a line, and we're going to use the letter m. So rate of change equals m, which equals our rise over run. So remember our rise over our run on the graph. We'll take a look at that in a second. And we see we've got y2 minus y1 and x2 minus x1. And on our graph here, we show an example of that. Our x1 and y1, and our x2 and y2. So we use our rise over top of our run in a fraction form. So that's m. When we find the initial value, we are finding where the line crosses the vertical or the y-axis. The common math term for this initial value is the y-intercept, and we're going to use the letter b. So in your box, make sure you fill out initial value equals y-intercept, which equals b, and this occurs when x equals 0. So we take a look on our graph. Know that x is along the bottom, so when x is equal to 0, whatever that number is there, that's b, or our y-intercept. So in this case, it's 4. So the linear equation that we can write is y equals mx plus b. This is called the slope-intercept form of a line. Y is the dependent variable, prices here, and x is the independent variable, which is our distance in kilometers. So now we're going to look at the practical example here. So m, which is our rate of change, is y2 minus y1 and x2 minus x1. So we see y2 is 10 and y1 is 3. So 10 minus 3 gives us 7. And 5 minus 0 gives us 5. And when we do that as a fraction, it's going to give us 1.4. So the meaning of this rate of change is that the trip costs $1.40 per kilometer driven, and that's the price of a taxi trip. Okay. Next, we're looking for our initial value, which is b, and as we go up, it is 3. I made a mistake earlier. It is not 4, it is 3. So that means that the initial cost at the taxi is $3. So it starts off at $3, and then every kilometer it's going to go up $1.40. So the equation where, with what the variables represent, we have let c equal the cost and let k equal the number of kilometers driven. So c, so our cost equals 1.4 times k, which is the number of kilometers, plus 3. So that is our equation now from that. So that's our y equals mx plus b. Let's take a look at our next one, which is burning a volatile candle. So first we need to find our rate of change. So y2 minus y1, x2 minus x1, that's our m value. And as you can see, we've got a negative line now. So we're probably going to be seeing some negative numbers. So our y2, see that it's on the y, it's actually 0 here. So 0 minus our y1, which is 3.5. So 0 minus 3.5 gives us negative 3.5. Remember, think of it in terms of a number line. If we have 0, we're going to go back 3.5 when we take that away. So x2 minus x1. x2 is at 15. x1 is at 6. So 15 minus 6 gives us 9. And when we divide that out, we get negative 0.39. So the meaning of this rate of change is that the candle burns at 0.39 centimeters every hour. So our initial value, we need to take a look at what that might be. So as we can see, if we go up along our scale, we actually would hit at 1.75, and we take a look at the scale, we see that it's going up by 0.5 every time, and it's halfway through, so 5.5, and then up another 0.25, so 5.75. So now when we're writing out our equation, we have our height equals h equals the height of the candle, t equals the time in hours. So again, we're talking about our dependent and independent variables. So h equals negative 0.39 times t, which is the number of hours, and we're going to add 5.75 to that number. So with these examples, we've gone over how we are using our formula of the y equals mx plus b. So we found our slope. Usually we're looking for our y, which is our dependent variable, and we're using the information that we have, something like our x value. So we could find out what that cost would be in our first one here. How much would our taxi ride cost based on the number of kilometers that we're going, because we've found our slope and our y-intercept. Okay, so if we wanted to find out 8 kilometers, we can plug now 8 into where this k is. Or over here, if we wanted to find hours, looks like what this graph already shows us to the point where the candle would be at 0 height, and that's at 15 hours. So again, we are applying that m and that b into our things, and we are then using our independent variable and our dependent variable for that. So that's how we can use those equations and find those equations based off of our graph. Next up, we're going to look at how are we going to graph lines using our slope-intercept form of a line, so our y equals mx plus b. So how do we graph this now? So if we know the slope and the y-intercept, we can draw a graph of a line in 4 steps. This method requires that you have the equation of the line and can read the slope and y-intercept values. So we need to know how to use this in order to graph things. So the first thing we need to do is we need to plot our y-intercept, which is b. Our next step is we are going to plot the slope, and we are going to go up by the rise if it's positive slope. So if our number in front is a positive, and if it's at a negative number, we're going to go down by the rise. So again, that's to do with our rise over run. The next, we're going to go right by our run. So we'll see down here, our rise here is -2, so we would go down 2, and our run is +3, so we're going to go right 3. The next thing we're going to do is we're going to plot a point where you end up and draw the line. So we're going to draw a few lines on there. That way we can have a good line there, and we can draw it and continue that line out as we go. A tip for you is that if the slope is a whole number, what you're going to do is you're going to put a 1 underneath that. So if our slope is 3, what we need to do is we need to make sure we put it over 1. Okay, we need to have that fraction so that we have our rise over run. And what that means is we would go up 3 and right 1 with that there. All right, so now let's take a look at the example here. So our graph or equation here is y equals -2 over 3x plus 4. So again, we know that our top number is our rise and our bottom number is our run. So we need to first identify our slope and our y-intercept. So m equals -2 over 3, and our y-intercept, which is b, is +4. So that way we know where we have to start on the graph and go from there, so follow our steps. So we see that we have to first plot our y-intercept. So we're going to go on our graph and we're going to go to 4. And we're going to put our first point right there. Next thing we're going to do is we're going to see our rise over run, so -2. So as I said, we're going to go down 2. So we're going to go down 2 there, and then we're going to go to the right 3, 1, 2, 3, and we end up right there. We want to put another point. So now, in order to make sure that this is a good straight line, we're going to put in 1 more. So we're going to go down 2 more and to the right 3. So every time we go down 2, we're going to go over 3. So with this graph. Next graph, we have y equals 2x minus 5. Again, first thing you always need to do is identify the slope and y-intercept. So m equals 2 over 1. Notice how that is a whole number. So when we are writing out our slope, we do want to write it out as 2 over 1. And our y-intercept is b is -5. So right off the bat, we know we got to go to -5. We've got our x-axis and our y-axis. So x equals 0. We're going to go down to -5. And now we're going to go, now we're going to take a look at our rise over run. So we're going to go up 2. So up 2, and we're going to go to the right 1. Then we're going to go up 1, 2, and go over there. So we can follow this along, and it should always follow along that pattern up 2 over 1, up 2 over 1. So if we wanted to continue this on, we could see what those numbers would actually be. So that's how we would graph based off of our line equation there. All right, now you guys are going to get to work on your practice questions.